Hey everyone, welcome again to my YouTube channel, and today we are going to solve a new question from our top interview 150 question series, and the question title is container with most water. So let's read this question first. So you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height I. So what we have been given is that we have been given an integer array height. Here you can see an example, and what it is given that these are all the heights for each of the line, and it is given that the starting and the ending position of this line are given, which is respectively I comma 0 and I comma height I. Here at the lower point it is I comma 0 and the top it is I comma height I. Now what we have to do is that we have to find two lines that together with the x-axis form a container such that the container contains the most water. So what we have to do is that we have to find two lines such that it consists of the maximum amount of water, or it can store the maximum water in between. Now we have to return the maximum amount of water a container can store. So we have to return that the amount of water it is storing. And here we can notice that you may not slant the container. So it is given that we cannot tilt this container. So it is simply as stable as it is. Now let's understand this question. So how we can proceed. So I have taken this example from our first image, and what you can see is that there are the two lines. This is the first and this is the second line, which is storing the maximum amount of water. Now what is the approach which you can follow is that you can see that for storing the maximum amount of water, what is going to be our parameter. So you can see that to find the maximum amount of water, we have two parameter. First is length and second is height. These two are going to dictate our amount, because if you have the maximum length and maximum height is going to dictate it. So in this example you can see that we can maximize our length simply because when if you start from the first index and you are taking the last index, that means your length is already been maximized. So if you take these two lengths, that means first one at the start length and second is the last length, you are going to maximize our length. Now the one point which is only left is that we have to maximize our height. Now let's see how we can do that. So let me first erase this. So as we have discussed that if we take the first line and we can take the last line, we have already maximized our length. Now to maximize our height, what we can do? So one thing we need, that you can here see that the water it is storing by taking this two lines is going to be this much water. So this much water is going to be stored in between. So to maximize this amount, what you can do, you can increase either this height or this height. You have only two options. So let's think what will happen. So if you increase this height, it doesn't change anything because our height is going to be this only. Because if you increase this height, so water is going to be a spell out and only left is going to be the height which is minimum. So you can see that the length which is minimum is going to dictate the amount of water it is storing. So in order to maximize the water content, you have to increase the minimum length. So what we can do, that if we find that our first index is minimum, we can move our first index to the next index. And now we check that how much water it is going to store. So in previously we have already stored the amount of water. Now we will do this and we can store the maximum amount of water stored every time. By doing this approach, what you will get is that the maximum amount of water which we can store in between. So this is the simple approach which we are going to follow, that we are going to increase or move our pointer which is the lower one, or which has the smaller height between these two pointer, or you can say between two lines which is containing the water. So let's code this and understand more clearly. So let's start by taking the length which is going to be height dot size. So we have stored the length of this vector. Now what we have to do is that we have to take two pointers, which is first at the first index and next is going to be at the last index, that is L minus 1. And why we have taken that, we have increased our, or I can say maximized our length. So we have to only think about the height now. Now what we are going to do is that we are going to run a while loop. And in while loop, until our I is less than j, what we can do is that we can check a condition. And the condition is going to be until our height, if our height I is less than height j. So if our height I is less, so what we can do that whichever height which is less, we can increase it, because if we increase that height, our amount of water is going to increase. So we want the only point, that means we have to increase our water. There is a possibility to increase our water, so we are going to doing that. So what we'll do, we increase our height. Now in else part, what we have to do, we have to decrease our g, because at this time our g is going to be small. Now next what we have to do is that we have to also store the water content at that time. So we are going to take a temp variable and we are going to store it. So what we can do is that first let's take the length. So we can take length by j minus I, and now we have to multiply it, and which is going to be dictate our height. So as I have mentioned that the height which is minimum is going to dictate. So we are going to find the minimum of height I, comma, height j. So minimum of the height is going to be define our volume. Now what we have to do is that we have to check and store this value. So what we can do is that we can store a variable value which is going to be answer equals to 0, and we can update this answer. So we can take ans equals to max of ans comma temp. So by this approach we can maximize it. Now let's return this answer. So this is the code. Now let's try to run this code. So it is accepted. Now let's submit this code. So it is successfully submitted. So this is the code and this is the question for today. It is a simple and straightforward question. Thank you all.